Hey everyone! The joke of the day today is, why do bees always hum? Stay tuned for the answer. Okay, we are going to continue looking at dividing monomials, but now we are going to think about monomials that might have zero exponents or negative exponents. Okay? Well, first of all, the zero exponent property tells us that anything, okay, and I repeat, anything to the 0 power equals 1. Okay, we've seen this with numbers and variables, but now let's look at it with monomials. If we're looking at this very first one here, okay, there's all of this stuff on the inside of the parentheses, but ultimately that's all being raised to the 0 power. So it is equal to, if we think about our 0 exponent property, anything to the 0 power equals 1. That means that this whole thing is equal to 1. Pretty neat, huh? Okay, well that one was pretty easy, but this one gets a little bit trickier, or maybe not quite as easy. Okay, we have x to the 5th, y to the 0 over x to the 3rd. Okay, well right away we know that y to the 0 is going to be 1. So this simplifies to just x to the 5th. We could put in the times 1, right? Times 1 over x to the 3rd. Okay, I'm just going to erase that times 1 because we don't really need it. Okay, so now we have x to the 5th divided by x to the 3rd. Okay, that's what we did yesterday. So we have this is equal to x to the 5. Oh, sorry, messed that up. All right, x to the 5 minus 3, which is equal to x to the 2, x squared. And that's our final answer for that one. Okay, let's look at this one. Again, we have a lot of stuff on the inside here that looks really hard, and we could simplify that if we wanted to, if you want some extra practice, but we don't have to, right? Because that's all being raised to the 0 power, and anything to the 0 power is going to be equal to 1. All right, anything to the 0 power equals 1. Okay, now we have a few more steps in this one again. So let's look. We have b to the 4th. I'm going to skip the step I did earlier. So we'll do b to the 4th divided by b squared. Okay, well that's b to the 4 minus 2. And then we have c squared divided by c. Well, this is really c to the 1st, right? So we have c squared, or c to the 2 minus 1. Okay, and then d to the 0. We're just going to say that's multiplied by 1. Okay, we can simplify that a little further. B to the 4 minus 2 is going to be b squared. And c to the 2 minus 1, that'll be c to the 1, or just c. Okay, so 0 exponents actually make things a little bit easier for us most of the time. Now, negative exponents, this is like the inverse. Okay, so when we have a negative exponent, we want to flip the monomial over the fraction bar and change the sign of the exponent. Okay, so what I like to think of it as, if we look at this one here, we have n to the negative 3. And when you're negative, that means, you know, maybe if you have a negative attitude, you're not very happy, right? You're negative. You're not happy where you're at. Okay, so we're going to flip it. So this is like n to the negative 3 over 1, right? Well, n to the negative 3 isn't happy up there in the numerator. So we're going to flip it to put it in the denominator, make it positive. Okay, so we'll actually flip this over, and so it'll be 1 over n to the 3rd. Okay, now he's positive. He's happy where he's at. Okay, let's look at another one. Okay, now this one we have 1 over b to the negative 2. Well, again, b to the negative 2, he's negative. Okay, he's unhappy. Make a little sad face. Unhappy, that's a terrible sad face. Oh well, I'm not an art teacher. All right, 1 over b to the negative 2, he's negative, he's sad. Okay, let's make him happy. Let's flip him. Okay, so he's b squared over 1. Okay, flip him, make him positive. Now he's happy up in the numerator, and b squared over 1, we can simplify that to just b squared. Pretty fun, huh? All right, now this one we have a few more negatives. And what we want to do is we want to make them positive. Okay, so we'll look at our n to the negative 5. He's sad. Well, that's really bad. Anyway, he's sad. And our r to the negative 2, he's sad too. So let's see. We want to put our n, if we're going to make our fraction bar, we want to put our n to the negative 5. We want to make it positive. Okay, we're going to put that in the denominator. Our p to the 4th, happy up there in the numerator, so we'll leave it up there. Our r to the negative 2 is unhappy in the denominator. So we're going to move him up to the top, make him positive. There we go. So we'll end up with p to the 4th, r squared, all over n to the 5th. Now let's take a look at what we might do if we have more than one variable. Okay, so here we go. Or if we have coefficients, that's a big thing here. So let's look at our coefficients in this one here. So we have a 5 on the top in the numerator and a negative 20. Okay, we want to simplify those. So we can just even think of it as just 5 divided by 20 or negative 20. Well, we can divide the top, the numerator, and the denominator both by 5, right? And that will get us to 1 over negative 4. Okay, so we're going to have in our numerator, we're going to have a 1 we know, and in our denominator, a negative 4. Now there are a couple of ways we could do this next step. The first thing I want to do this time is make all of my monomials happy. Okay, so we have our negative, our r to the negative 3, he's sad. So we want to flip him, put him on the bottom. We have r to the 3. He's positive now, happy there. Okay, our t to the 4th can stay on top because t to the 4th is happy in the numerator there. And the same with this r squared here, that can stay in the denominator. Our t to the 7th can stay in the denominator. Oh, but our u to the 5th isn't very happy. He's negative. So we're going to switch him to the numerator, make him happy up there, positive. Okay, well, we're getting there. So the next step, we already have divided our coefficients. Those are as simplified as they can be. Well, and we don't really need that 1 because it's a 1. And anything multiplied by 1 is just whatever we had before. Okay, but we can keep our negative 4. Okay, well, we have this r cubed and r squared. Now we're just multiplying those together. So we will add the exponents to make that r to the 5th. Okay. And now we got to look at this t to the 4th and t to the 7th. Well, those we are dividing, so we're going to subtract the exponents. So we have t to the 4 minus 7. So 4 minus 7 is negative 3. Okay, so we end up with a t to the negative 3 in our numerator. And that u, there's only one u, so we still have u to the 5th. All right, we are closer, but still not quite done because now our t is unhappy in the numerator. So we are going to move him back to the denominator. So on the top, we should just have our u to the 5th. Then we have our negative 4, r to the 5th, t cubed is going to be in our denominator. And that is our final answer. Let's look at another one that's similar to that. This one here. Okay, we can look at our coefficients, right? So we have our 2 divided by 10. Okay, well, 2/10. We know that that simplifies to 1/5. Okay, so I'm just going to draw my fraction bar. We have a 1 and we have a 5. Okay, well, our a squared up here is happy up there. Our b cubed up there, happy up there. Oh, but our c to the negative 5, he's unhappy. So let's switch that to the bottom and change the exponent. Okay, make it a positive. Oh, and this a to the negative 3 is unhappy in the denominator. So we'll move him up to the numerator, make him positive. Same thing with this b to the negative 1, b to the 1 in the numerator, and this c to the negative 4. Okay, c to the 4 in the numerator. now let's combine our like variables. Let me get a different color. Okay, we can still keep our 1, and, well, we actually don't even need the 1, right? But we can keep our 5. And in our numerator, we have this a squared and a cubed. Okay, those are just being multiplied, so we should get a to the 5th. We also have a b to the 3rd and a b to the 1st. We can add those exponents to get b to the 4th. And then we have a c to the 4th divided by a c to the 5th. So we will subtract those exponents to end up with c to the negative 1 in our numerator. All right, well, now our c is unhappy, so we want to finally make him happy by flipping him to the denominator. So we will end up with a to the 5th, b to the 4th, over 5c. And we don't really need that c to the 1st, right? Really c to the 1st, but we can just erase that out of there. For this final problem, I'm going to show it to you a different way, so we can think about maybe there are some other ways that we can solve these, okay? So we still have our 32 divided by our 4. Well, that's easy. We know 32 divided by 4 is 8, so we'll end up with 8 in the numerator, okay? And instead of switching our negative exponents to making them positive, right, by flipping them and taking the inverse, we are just going to do all of the subtraction right away. So actually, I don't even need this fraction bar yet. Okay, so we are going to do this. It looks like we have a to the negative 8, and we have minus 3. Okay, because we had a negative 8 exponent on the top and a 3 on the bottom. Okay, times b will be to the 3rd minus 5. Okay, b to the 3 minus 5. And then for our c's, we have c to the negative 4 minus c to the negative 2. This is where it gets a little confusing. C to the negative 4 minus negative 2. Okay, now that I have all that, let's simplify this. So we'll end up with 8. And negative 8 minus 3, that gives us negative 11. 3 minus 5, that gives us a negative 2. And c to the negative 4 minus negative 2. Okay, well, we can, subtracting a negative, it means we're adding. So we have negative 4 plus 2, which still gives us a negative 2. Okay, now that we have this, we can think about this as all of this being over 1, right? And we can move our unhappy exponents to the denominator, okay? So we have all 3 of these are negatives, so they're all unhappy. So we'll just end up with 8 in the numerator over a to the 11th, b squared, c squared. And that's our final answer. All right, why do bees always hum? Well, it's because they don't know the words. Have a great day.